Hello, everyone, and welcome to this Mobile World Live webinar. I'm Kavit Majithia, Managing News Editor of Mobile World Live, and I'm delighted to be your moderator for today's event. Over the next hour or so, we are going to be exploring a fundamental element required for 5G networks to operate: resilient, precise time synchronization, and how the country of Sweden is taking steps to ensure operators in the country are not solely relying on GNSS for this function. Now, this is a very interesting and perhaps under the radar industry topic, given the fact that the current global geopolitical landscape is affecting resilience of GNSS, traditionally the most used sync source. Disruptions and outages through jamming and spoofing are now becoming a recurrent phenomenon, and Sweden quickly moved to act to explore alternatives. To discuss this topic in more detail and delve into the steps Sweden has taken to secure national resilience of 5G, I am joined by three speakers today. Firstly, we have Karin Au, who is the CEO of NetNode. Hi, Karin.
Hi.
Great to have you. Second, we have Hans Strohsand, who is Product Director Synchronization at Net Insight. Hi, Hans.
Hi. Hi.
And finally, we have Håkan Andersson, who is Mobile Transport Network Specialist at Free Sweden. Håkan, great to have you.
Hi, everyone.
Now, while our speakers are presenting, I'd like to encourage our audience to interact by posting comments and questions. We will have time at the end of the presentation to address some of these questions. Submit a question in the box underneath the slides, and we will try to answer it. And with that, we will kick off with you, Karin.
Thank you. And thank you for inviting me to speak on this webinar today. We are very happy to speak about time and what we do in Sweden, because it's been a long project and we are finally seeing some success in customers relying on our time services. And we're also happy to be here together with both Håkan and Hans from Net Insight and from Free, one of the operators in Sweden. NetNode is a small company. If you don't work with us, I don't think we are very well known. We work with IX services, DNS, and time and frequency. Time and frequency has been one of the babies of our products, if I say so. It started very, very small as a project between us and the regulator in Sweden, PTS, and also the NMI, RISE. Next slide, please. So, the Swedish model is actually based on a demand from the regulator that the operators in Sweden shouldn't be relying on GNSS or any satellite-based synchronization services for 5G or 4G for that matter. And it started back in 1997, where our company was founded, and we had the first NTP server up and running. So time and frequency wasn't all new to us. We've been part of the NTP pool for many years. But during the 90s and beginning of 2000, we had a few incidents in Sweden leading up to lots of discussions and projects together with the government, where they were discussing how to secure time and frequency distribution throughout the country. And there was a few demands and the challenges, of course. We were among several other operators in Sweden who had an interest in this, but something that makes us stand out is that we are neutral. We have a very special ownership in the background from a foundation, which makes us non-profit driven. And this was one of the key elements on why we got commissioned to establish this distribution network. So what we do is that we provide GNSS independent time, and it's traceable to the Swedish UTCSE timescale, and we offer free and also some commercial services on different SLAs and with different characteristics and accuracy to different sectors in Sweden. And the 5G mobile operators, they need to distribute time from the national clock source of NetNode, our company, to the different 5G radio access networks throughout the country. There are also a few requirements. If we go to the next slide. There are a few requirements put on this system, and I think I want to mention a few of them at least. And it was very clear from the beginning that we had to have a national perspective and that we could guarantee a robust and secure time system from the north in Sweden to the south. And as I'm sure you're aware, Sweden is a small country, but we are very stretched. So this has been a challenge for us from the beginning. I will show you in the end a map of the country where we have our different sites. It needs to be robust and it needs to be available in the whole country. The same robustness, the same scalability service-wise, and that is also a challenge for us. One of the key elements is also that price can't be a barrier for usage. That was one of the very clear messages from both the government and the regulator. So we have a model in Sweden. If you're one of the national operators listed at the regulator, you have a service fee, so it's a very low key cost for you to enter and use these services. That has been a success on the operator side, but if we look into other sectors later on, I will speak about that later on. We don't have the same price scale for them. Also, as we are funded from the government in the end, they also have a clear demand that they need to have a visibility and direct input. They need to be able to trace what we do and see how we are scaling this project, which means that they are included both in the yearly overview of everything, customers, development, rollouts, etc., but also that they adjust the funding for the system. If we go to the next slide, we can look at the funding model and how it's been set up. We are actually 3 parties in this project. NetNode, our company, we have RISE, which is the NMI, and we have PTS, which is the Swedish Post and Telecom Authority. They are funding us through a fund called Robust Electronic Communication Fund. It's not only for us, it's also redundancy on fiber paths, you have emergency power, you have all sorts of robustness in the telecom sector, more or less, who can apply for funding. And it's built up by 1 ppm of the turnover from the different telco operators, and it's matched by as much funding from the governmental side on a yearly basis. And one of the biggest success factors in this has been that we have a very long-term cooperation with the government and with PTS on funding. Otherwise, it's been very difficult to see how you can put through such a big investment throughout the country. If we go to the next slide, how we look at redundancy and robustness in Sweden. As you see, we are a very stretched country, if you weren't aware. We have our most northern sites up in Luleå and the southern site in Malmö. On each site, we have a dual node, which is all the critical equipment is doubled for robustness and redundancy. And these nodes are put in secure bunkers in each location. These bunkers has been one of the military's fortresses before, but it's now owned by Telia as an operator, and it's turned into different co-location sites. And we are situated on 6 of them. As I told you, all the equipment is doubled on each site, which means we have 2 cesium clocks on each site. Between each clock, we have also fiber paths, so each site is redundant to each other. And all of these sites produce a timescale, and each timescale is also traceable to the Swedish national time, and we calibrate each site and each timescale towards the UTC SE. And the last slide, if we go to that one, lessons learned from establishing the distribution network throughout Sweden. Of course, we learned a lot. It's been a long ride, only a few years, but still we've learned a lot. So developing this kind of infrastructure and distribution network, it's not only a big cost in equipment and in sites, hardware, you also need to find the right level of expertise. Not only find them, you need to hire them, which is also difficult. We've been working quite a lot with that. It's a big investment and it demands also cooperation. So Net Insight is one of the partners that we have in this. We do different things in this whole chain of activities that needs to be done to deliver time and frequency throughout Sweden to customers. This private-public cooperation is something that we usually get to talk about because it's quite uncommon that it's working as good as it has been. And I think from the beginning we defined the different roles and the different areas to address for each player in this. And that has really been a success for us. And we know also that the government and the regulator are very happy to see this as a success. Also, given the geopolitical circumstances right now, as we mentioned in the beginning, the robustness is more crucial now than it's ever been. We work a lot with robustness, redundancy. We always look into new and more infrastructure paths throughout the country, and to deliver this time between our nodes in a better way. So this is something that we are continuously working with. Also, we need to stay ahead. We know that time distribution requirements and technologies are constantly changing. We know that there are new clocks on the market. We are currently actually exchanging the old clocks that we have to new ones. So we always need to be out there on conferences, meeting with distributors to see what is really going on in the research field to stay ahead. And what is really, really funny, like what we do right now, there is a lot of interest from other countries, other regions as well, how we did this. And we are happy to talk about it and invite you to our sites, together with Net Insight and together with other partner companies, of course, to see how we can do this and discuss with you. But the interest is rising, and that is, I think, that shows that time is really a crucial element right now for many sectors. Thank you.
Thank you, Karen. That was a very insightful presentation. I had a couple of questions. The first one touches on your last point. What is the most common questions you're getting from other countries now getting prepared for this?
One very common question is awareness from the sectors. How do you create awareness? Do they really know that they need time? Can you sell it as a service? That is one very common question. I think that Hans will also get back to that. The customers today are getting more and more knowledgeable, but of course in the beginning that was a true challenge.
Sure. And is there, besides telecoms, is there interest from other industries also in this?
It is. Now actually the interests are waking up, and we can see the energy sector is one of the biggest sectors. The first one was the operators in Sweden. Now the energy sectors, we had a big energy crisis in Sweden last year, and that also put the spotlight on different challenges for the sector, which clearly was time and frequency as part of that. But we can also see banking and finance. They have also a regulation called MiFID II, which is time stamping and very exact and precise timing. We can see the gaming industry coming back to us now. So there are several sectors and industries waking up right now and asking us for new adjusted services aiming towards a specific area.
It'll be interesting to see how it develops. Hans, over to you.
I think, Sweden was relatively early realizing that we have an over-reliance on GNSS. There are so many critical systems and functions that rely on GNSS for synchronization. The mobile networks being one of them. And today there are a lot of activities in US, in EU, in various countries to kind of mitigate this over-reliance. And I think one example was this Christmas event that we had in Scandinavia, where somebody in Kaliningrad essentially made a significant disturbance in all of southern Sweden, part of Denmark, Poland, and a few other countries. So I think the awareness that there has to be an alternative to GNSS for synchronization has kind of risen. And the PTS, you can take the next slide. The PTS mandate a couple of years ago, that kind of came, I think all operators were working how to make their networks more robust. But the PTS mandate that you have to have a national source and you have to have GNSS independent transport of time in the entire network kind of force that transition to network-based timing. And when you are a regulator, your requirement has to be fair. It has to be implementable in a reasonable way. And the fact is that the traditional way that telecom has chosen to distribute time is using PTP and using a model called full timing support, which essentially means that all network elements in the network must be timing aware. So an operator distributing the time from net node to its network, they must ensure that every router in the network is timing aware, and every line card in every router supports PTP, and even every line system that transports the traffic must also support PTP. So to upgrade and support this full timing support is for many people very, very difficult and comes with a huge cost and complexity. And now kind of enters Net Insight because we don't come from telecoms. We come from media and broadcast, and media and broadcast, we have always been considered critical infrastructure for some reason. A mobile network has not. So we had a GNSS independence mandate quite early, and how broadcasters don't own their entire network. So there we developed a way to send the synchronization with the media streams. So how we implemented it is that we send the transfer through the network as a service. And we kind of use an in-network overlay distribution, which makes it completely independent of the underlying network. And there is no PTP requirements on each and every router or optical DVDM transport. And also you get, I mean, as with all the other services in the network, you get the kind of end-to-end observability and management. So I think there was a very large operational benefit that telecom now starts to realize that this is a really good model to use to distribute timing instead of the old PTP. And telecom has now kind of noticed this, and the standardization body of telecom, the ITU-T, has opened a work item which is called Enhanced Partial Timing Support, where we actively work to take these features and take these abilities and make it a standard. And we work together with, other partners in this effort to kind of do overlay service possible in a standard way. And Huawei has made contributions where they're proposing to add bidirectional synchronization, for example. And Juniper last Congress proposed to add that you should distribute time between all peers and not only the elected master and these things. So I think that telecom is actually starting to kind of come together to start sending time through the network in an overlay fashion instead of having it in each and every route. Yeah, thanks.
Hans, thanks for that. So just a couple of questions here. How do you see this developing globally? Is it something being enforced by regulators only, or do operators see the value in it?
Yeah, yes. I mean, operators, they see the value, but it's also they before they kind of saw that they came with a huge cost and complexity, and now they're kind of looking in how to solve it in a more flexible way. And also there is a lot of activities inspired by NetNode and the Swedish model that, how can we distribute it? Where do we make the time? Is it the time as a service? Is it available in every coloc? Is it available in every point of presence? Or should we have these kind of central ePRTC? So I think there is a lot of activities in a lot of countries to introduce the possibilities for network-based timing.
And another, in terms of other sync solution alternatives to GNS and SS, how do you see discussions and interest for these? Like, for example, LoRaN.
Yes, as well. Those are more country. For example, the initiatives in US by Department of Homeland Security, they are looking at alternative to PNT, and network-based timing is one of those, of course. There is initiatives in EU doing the same thing, and then also individual countries, of course. But I think there is a lot of activity all over the world to solve this.
Thanks, Hans. Håkan, we'll end the presentations with you.
Yes, hi everyone. I will share the presentation here. Hope it will appear on your screens. Yes, Håkan Andersson. I'm working with Transport Solutions here, the mobile operator 3 in Sweden. And I'm referring to what Karin mentioned about the 5G auction that was held in 2021 for the 3.5 5G spectrum that was held. But the next auction was actually held in last year, 2023, and there were the spectrum for 900 and 2100, 26 plus the 2600 TDD band as well. And here we see the same requirements from the authorities. So they have kept these requirements that the synchronization solution must be GNSS independent. And I think those requirements will be kept in the next coming auctions as well. As you saw the map from that Karin showed, we have actually what we have done here in Sweden is actually to connect to those sites to get these backup atomic clock solutions. And I think we were quite early by connecting the first ones actually. So they have been there actually before the requirement came. But when it came, it was just good to know that we have that kind of backup, so to say. But distributing the frequency on those new band that only requiring frequency, that is one thing. But distributing time phase over the whole from the 5G core or from these atomic locations, peering points over the mobile transport network to the access layer where we have the NR sites. There's a really challenge, I would say. And the challenges consist of, for example, in the backbone, you might face asymmetry problems. We have different platforms with a deviation of constant and dynamic time errors. We have in the backhaul, we have several number of termination points where we lease capacity for as VPLS services that we buy from different vendors, and they don't have any support of synchronization or neither SyncE or G8275 or what it can be. So what we are doing by these time transfer node is actually that we insert the Syntype time transfer node from these peering points, so to say, building a time domain for this one, and adding a time transfer overlay. And this is done by doing it on a pure layer 3 VPN service between those endpoints. And from the PE route you see here on the left, we actually, the last mile in the access network, we distribute the time and phase as SyncE in combination with G8275. So the time transfer domain in more detail looks like this, that from the right hand, we have the net node peering point serving us with time and phase, and connecting to the grandmaster, which also is connecting to the GNSS as a primary source. And the time and phase is then mapped into time transfer into the time transfer timing domain, so to say. We transport the time and phase signal out to the edge on the access towards the access network, and there you have a time transfer node primary synced by a GNSS, and the last mile, as I said, is distributing by SyncE and G8275.1, and this requires, as you know, fully support on all devices. And we also have a connection towards adjacent time domains in case of these net node connections or any hardware will malfunction here. And all these links on all time domains, they are frequently monitored, and they are also frequently calibrated actually to obtain a minimum time error, and they will take over if the local GNSS fails on the site here. And as I said, we can monitor all links, so we have an overview of the performance of the links. And here is just an example what you see here on the top. But if you want to do a deeper analyzing in one of the links, so to say, we can do a deep analyze and go through all telemetrics, and it's and by this I can say also that you are learning a lot from the network about the behavior. Yes, so that what's the last slide for me. So please go on.
Håkan, thanks for that. We've talked a lot about the potential problems that can occur with GNSS, but do you see the issues with GNSS today also?
Yeah, except for the threats that we know all know quite well about, local jamming, for example, atmospheric conditions that can cause interruption in the GNSS receivers. We have also a lot of sites that not every day some sites have bad antennas, make phase synchronization not achievable. And we have also a number of indoor sites serving, it can be big arenas, for example, and they have probably a local GNSS connected to that one. But it's very good to know that you have a backup solution in the back if some GNSS will fail to these sometimes very important sites that that carries a lot of traffic. Because if you don't, for example, a 5G cell that is not phase locked, the cells will go down quite fast, I would say, if they lose phase and time synchronization. So I would say, yeah, it's good to have this grandmaster with backup sync from those net node peering points. Yes.
And you're up and running with this now. Do you have any reflections, takeaways on how it's working?
Yeah, as I showed in the last slide, we can actually see and monitor all the links and see how the performance of it. And as I said, it's also very learning and interesting to see with those detailed telemetric data that we actually get from this system, that yeah, we can actually see what happens in a network. For example, if the router will reroute the traffic, we will see that directly on the telemetry data. And we can also analyze the noise figure of the time transfer link itself and see how bad or good the time deviation is, the time error is on the links. And yeah, and the system handles actually, we have done quite many tests to see how the system handle different failovers. For example, like GNSS failed on this edge site. Will it turn to the time transfer link directly and continue to distribute PTP? Yeah, and the answer is yes. It seems to work really good, I would say. So yeah.
Thank you, Håkan, and also Karen and Hans for the presentations. So we'll move over to the Q&A section of this webinar. We've already had some great comments, and there's still time to ask the question. Just use the box underneath the slide presentations, and we will do our best to cover it. Karen, you haven't spoken for a while, so I'll give the first question to you. How is Sweden facing the cyber threat in their situational awareness regarding actors potentially threatening and targeting reliable time sync services distribution?
That is a very interesting question. If you don't know NetNode, I can give you a short background. A lot of my employees were among the people establishing internet in Sweden when it all began. That means that they have a very, very deep understanding in how they can build up and set up fiber links and internet and distribution networks. With that being said, we work quite a lot. We have a big security and cybersecurity organization in the company. We, of course, see that there are GNSS disturbances around the coastal line primarily. We haven't so far been attacked or threatened or exposed to it as such, and not directed to our time service. But of course, we can see that lots of our customers are being affected, and we work together to have more robust solutions all the time. And we work together with the government. We report back to PTS with everything we see on a weekly basis. So we are constantly on the topic, and it's never a calm period, I would say, for the moment. And I guess that's also why we could see that this land-based and fiber-based distribution network is so important.
Sure, makes sense. Question here for Hans. Is GNSS independent sync for 5G networks a current ITU-T standard? And another question for you, is NetInsight on the Q13 at the ITU-T 5G 15 discussion board? If you want me to repeat that, let me know. You're on mute, Hans, sorry.
Sorry. Yes, we are participating in the ITU-T work. I mean, and we are spearheading the work on EP, the enhanced partial timing support. So yes, and I mean, before it was a lot of people that thought that telecom people that thought that full timing support was the only way, the only standard, the only way forward. Therefore, there's been quite a lot of focus on that. But I think the I2T is now kind of taking up this the overlay way of distributing timing, and I'm really looking forward to working in I2T with all the membership companies there in question 15, study group 13, I think. Yes.
Great, thank you. Håkan, I'd like to understand how you can achieve sync requirements for 5G needs in a multi-vendor, non-harmonized sync functionalities environment. Could you shed some light on that?
Yeah, sorry. I think I heard a question. I have some disturbances here on the quality, but when it comes to last mile for all nodes, where we actually provide phase and time, it of course require fully support for all the elements, and we are only providing or configure those two functions in the network where we have the C-band sites, and further on, as I showed in the slide, we also obtain the spectrum for the 2600 TDD, and they will need to be configured as well later on. But yeah.
Karen, back to you. Why do all EU countries not work together to arrange for neutrality concerning PNT issues?
I think that this has been a difficult discussion between the different countries. They are taking steps ahead right now as we actually sit here. I think also it's we have different developments in each country. No industry body gathering us in the discussion so clearly. And that needs to be done to facilitate the discussion and to make us cooperate. We are trying now, there are a research program actually on this level between all the EU countries, which is very interesting. And I also know that the NMIs in each country are trying to participate in that project that will also push for this to happen. But it will take time for us to cooperate around this. We have very different approaches on how to deliver time and sync in the countries. Some of us do, some of us don't. Not even the Nordic countries cooperate in this so far. It's a very national topic.
Right, makes sense. Hans, is this time synchronization available also for private networks?
Yes, I mean yes, because I mean the private 5G networks they have the same mandate for PTS in their interface to be GNSS independent, and they have exactly the same issue that Håkan had, that they rely on least capacity to get to these private networks, and so yes, we are working with a couple of private 5G. It's still not a gigantic business. Very much of the private mobile networks are still on 4G. But I think when they go TDD 5G, it will be quite huge, and they can use the same technology as the service providers. It's just that, I mean, they also may have to have a redundant connectivity, for example, which the operators always have, which maybe they didn't have before. So yes, you have to work with the network like Håkan does, and you have to also look on these more innovative solutions than just rely on old ITU specs.
Sure. And Håkan, coming to you. What time precision can be delivered over 5G? Are we talking microseconds? Are we talking nanoseconds?
Yes, if we look on all the links that we have today, we look in the overall of those links, I will say most of them, they are within 100 nanoseconds, but many of them are below 50 nanoseconds. Just a few ones can differ sometimes and might need to perform manual calibration on, but the system itself, it auto calibrates all the links very frequently. So but I would say I'm really impressed of the high accuracy, and by using multiple links towards these endpoints that I showed on this time transfer node, you will have a more robust algorithm doing in the end a better time error.
Okay. Karen, is NetNode connected to UTC-K over fiber or using Common View GNSS?
Over fiber, but we also use Common View as a backup.
Okay, that was short and sweet. Hans, how does timing cope with the lags from multiple handoffs from one carrying system to another? At the resolution that you might need timing, this could be significant.
Yeah, I think again, when you have this hop by hop notion of deteriorating sync, you kind of that is a key factor. But when you look more on the end-to-end transfer of time, that is not the case. I mean, then it comes more of how to cope with certain network inadequacies and issues on the network, compensate for events, network events, hockey games, Netflix hour, and these things. And you get less impact from these kind of individual hops or points in the synchronization flow. But the old ITU-T models was always how many network elements could you have, or how did they interwork? I mean, it's like Håkan says, we don't select the best sync flow. We kind of synthesize all sync flows together to create the best time out of that.
Mm-hmm.
So
Sure.
it is a little bit different problem when you're solving the network problem than just solving a simple router problem.
Right. Håkan, why distribute time sync on top of an existing IP MPLS network when there are ITU-T recommendations for distributing PTP such as G.8275.1 that work at layer 2 and achieve higher accuracy?
Yes, why not? The problem, as I said, in the previous slides, showing that when going over a different XWDM system, you will face asymmetry. You will have different platforms with different constant and dynamic time error, and how monitor that? But when we doing time transfer over these wavelengths, especially the longer wavelengths, we can actually see how noisy some of the links are, and I guess it takes a lot of efforts actually to analyze those segments if you don't have this kind of possibility to analyze the telemetrics you have. One experience I have myself by combining different platforms, for example, with G8275, they not work. The interoperability between the platform is not always optimal neither. So if you have a system with different vendors, you might face problems, especially and you get that the server goes down in some part of the chain, and they will come back and lock back again. It will take some time for you. Yes.
Okay, and Håkan, staying with you, you said that the access points and termination points need to be compatible with Sync E. Is this already widespread or only in a few handset manufacturers?
Those as I said, in the access point, we're distributing P2P as GAT275, and this is the solution at the last mile for us. And I think since those last mile often is a dark fiber or is a microwave link, that all equipment support time and phase. But if you don't have equipment that don't support this kind of the GAT275, then maybe you need to consider to actually move the Syntyc node further out.
Hans, what is the timing accuracy you can get from the solution?
Yeah, I get that question always. I mean, on a good network, you can distribute nationwide at a few 100 nanoseconds accuracy, but then you require, on a poor network, you would probably need a couple of hundreds but I haven't yet seen any operator network that hasn't been able to distribute time nationwide within the 1 microsecond time error budget. So I think, and also you have regional head ends, like Sweden have 6, so you don't need to transfer the time from north to south. But you have to have a backup point. So hopefully you don't need to distribute it from the US West Coast to the East Coast. But still, I mean, you create kind of regions with backup to other regions. So yes, within half a microsecond nationwide, I would say.
Okay.
As an overlay service.
Yep. Staying with you, how could Net Insight's synchronization solution be used in power grids?
Power networks and telecom networks are quite alike. So I think the technology to distribute it inside the power grids are essentially the same, and we have field trials. We don't have any sharp production networks with power grids, but we have field trials with utilities. The difference is the P2P. When telecom has this GAT275.1 and power has their own P2P profile, so the distribution inside the subsystem is very different. But the distribution of time to the subsystem is very, very alike, in my mind. So I hope we will use exactly the same solution. But yeah, like Karin says, that if there is two different areas, they always tend to optimize their own area. But it should be the same solution.
And Karin, what are the worst constraints in Sweden to this project, and what do you think will be the biggest constraints for other countries, such as low cost equipment with fallover, timescales, awareness, etc.?
The big constraint is actually expertise. There are not many people working with time and frequency that are really they are moving around. So we are trying to get people working for us with time and frequency, and I think this will be a big challenge in each country. Also, the model of cooperation within the country and between countries, that is also something that needs to be developed. We found a model in Sweden that works very well, I would say, but that also needs to be an active discussion all the time. We are contributing to discussions in different countries and try to facilitate it between actors and players. And it's very important to find each player's role in the setup in each country to make it a success. And that is crucial. Also awareness from different sectors. If you create awareness and you can reach a demand, that will be a good starting point. And you shouldn't start too big with different sectors. You need to focus on one sector. And I think, as you also said, Hans, the energy sector is really interesting. There are lots left to explore, both within and to the sector. Operators, of course, they have a very strong push as they are regulated very strictly. So there are different parts, but of course, I think hardware is not an issue. There are different vendors with different solutions. We don't go with a very expensive one. We go with a mid-size one. For us, that's enough. But also, we need to have a control over all technical equipment. So I think there are several constraints that needs to be overcome, but if you're aware of them, you can also address them early.
Question here for the floor, I guess. Have the recent space weather and northern lights affected GPS timing in Sweden and service resilience?
I don't know, Håkan, if you want to say something. We could definitely see something disturbing our GNSS receivers. It wasn't as bad as we expected, though. I don't know, Håkan, if you want to comment on that.
Yeah, I've been looking into specific jamming situations. I think until now we have been jammed in very local areas, but I know the day when the jammers come from above, then we got a huge problem, I would say. And just imagine how it can be done, but that's for sure. But today we have a mix of jamming situation and GNSS antenna fails due to water entrance and type like that. But yeah, okay. I think it's good to be prepared for worse situation, definitely.
Sure. Karin, it was mentioned at the start that some services are offered free of charge and others are chargeable. Could you elaborate a bit on the different service tiers and the different specifications for each tier?
So we have both commercial and free services, of course. You have the NTP and NTS service, which is a free of charge service, which you can either pick up from our website, just go in there and find them, or you can use a simpler one from the NTP pool, of course. The PTP service is the premium service that we charge for. Depending on what kind of parameters you want, what kind of equipment you need, there is of course also a difference in the charging, but we have also a NetNode Time Remote, which is a service where we put up a CP with the end premises, and the customer can be located outside our PTP area. You have not the same SLA, but it's good enough for the energy sector, for instance. And you also have NetNode Time Direct, which is if you are an IX customer of ours, you can pick up the time service from an IX port that you already use for other services, peering, for example. So we have different the SLAs, we have different technical parameters depending on your need. And also the pricing is various variations in the pricing depending on the parameters.
Okay. And another one here is, how is asymmetry countered considering the IP network might take different paths to route packets?
Yeah, I can take that. Yeah, I mean, those asymmetries is the easiest, actually. I mean, they are devastating to a PTP network, but those asymmetries are so easy to recognize and compensate for. So it's quite common that you get I mean, MPLS is unidirectional, so you can get a reroute in one leg. The asymmetries that are a lot more difficult to handle is the one which are created by the optical DWM systems. They are smaller, they could be buried in noise or traffic. So you have to be aware of a lot of different asymmetries and constantly compensate for these events on the network. But yeah, they happen all the time, and you have to compensate for it, not follow them, because then you will be off.
Sure. Another one, whoever is best placed can take it. Which customers are the major beneficiaries of critical timing and independent sync? And if this has a positive return on investment, how good is the ROI?
Yeah. Yeah, we are working because we are working with a lot of mission critical networks in different countries that I mean are facing these questions, and we are with the governments and sometimes with the regulators. We are trying to build a business case on how to create. I mean, for example, how should they build this timing service, and how much does it cost to the country, and how much may it benefit the mobile operators? Sweden has decided on this net node and then operators to distribute the timing. But for example, if the neutral networks and neutral host that's a trend today, both in mobile and in others, like shared infrastructure is good. So I think, yes, it's a ongoing discussion in the industry, and and also other industries, yeah.
Sure.
Including military.
So we're nearly
the green guys.
We're nearly out of time. I wanted to give you guys a chance just to have a final say. So for all our presenters, what advice would you give to your Nordic neighbours, to the EU, to the UK, and to other countries? Karin, we'll start with you.
That would be to cooperate in establishing new distribution networks, because it's a big task. It would be even better to cooperate to make it even more redundant and more flexible and reach even further than beyond your country limits, borders.
Hans, over to you.
Yeah, it is to build a robust network before the regulator kind of mandates it, because the business case to avoid a total network outage or the cost of an issue is like amazing. So really the advice is to build a network-based timing, even though you're not yet kind of enforced, but because you will benefit. Absolutely.
And Håkan, last but not least, over to you. What advice would you give?
So I have some quality issues here on the downlink. So please repeat the question.
Yeah, it was just for all presenters. What advice would you give to your Nordic neighbours, the EU, to the UK, and to other countries?
Sorry, I can't hear anything. Can you take that, Hans? Or
no problem. Hans, Karin, I think they summed it up quite well. So I think we'll wrap up the webinar there. Thank you, Håkan, Karin, and Hans, for your presentations. That was great. And thank you to our audience as well for taking part. If we did not get to answer your question today, someone from the team will try and get back to you. And if you missed any of the content, it will be shortly available on demand. Thanks again, and we will see you next time.
Yeah. Thank you.
Thank you.
Yep.